Let's do yet another problem involving pressures created by a column of fluid. So here we have a problem. It's a buried oil storage tank into which groundwater has leaked. And since the water is more dense than the oil, the water goes to the bottom of the tank. And we see that there's 3 feet of water at the bottom of the tank. And then above the water is oil that's gone all the way up into this filler pipe and to a height of 17 feet above the water. And we are asked to find the gauge pressure at point A and the gauge pressure at point B. And we're given the densities of the two fluids and acceleration of gravity. Now recall that gauge pressure and absolute pressure are not identical. And here we've been asked for the gauge pressure. So let's find them. I'll repeat the given data. The height of the oil is 17 feet. The height of the water is 3 feet. We have the acceleration of gravity and the density of the oil and the density of the water, all given for this problem. So let's write this equation. We know that the pressure at point A, the absolute pressure at point A, is the pressure of the oil plus the pressure of the atmosphere. So here at point A, the pressure is created by the column of oil above it, and then the pressure of the atmosphere pressing down on the surface of the oil. Okay, so once again, the pressure at point A, the absolute pressure, is the pressure of the oil plus the pressure of the atmosphere, and the pressure of the oil is given by rho GH, all using values for the oil. So we can substitute that, and now we have the absolute pressure at point A is rho GH for the oil plus the pressure of the atmosphere. Now, I'll state once again, we've got to remember that they're asking for pressure gauge. It's as if I were to attach a pressure gauge right here at this point A. And remember, a pressure gauge does not read absolute pressure. It reads gauge pressure. And the relationship is that the pressure, the gauge pressure, is the absolute pressure inside the gauge minus the atmospheric pressure outside the gauge. So we have this equation now. The pressure at point A, the gauge pressure that is the absolute pressure of the oil, which is rho GH for the oil, plus the atmospheric pressure, minus the atmospheric pressure. So the atmospheric pressures cancel, and we end up with the gauge pressure at point A is just rho GH for the oil. So carrying that previous equation, we have the gauge pressure at point A is just rho GH for the oil. We can introduce now the term G sub C, because whenever we have a G in an expression like this, we're going to have to divide by G sub C if we're using English units so that we can get the convert mass to force. So let's plug everything in. We've got the gauge pressure at point A is the oil density, 55 pound mass per cubic foot, times G over G sub C, times the height of the column of oil, which is 17 feet. And then I have to convert square feet to square inches because I want PSI, not pounds per square foot. So the gauge pressure at point A is 6.5 pounds force per square inch. That's gauge pressure, PSIG. Now, what is the gauge pressure at point B? We can do this rather simply. We can simply say it's the gauge pressure at point A plus the pressure of the water in between the two. And remember, the pressure of the water is rho GH. So we can substitute now rho GH for the gauge pressure at A, or excuse me, for the pressure of the water. And we have the gauge pressure at point B is the gauge pressure at point A plus rho GH for the water. Okay, so here's what we had. We had the gauge pressure at the bottom of the tank is the gauge pressure at level A plus rho GH for the water. Let's plug our values in. We know the The gauge pressure at point A was 6.5 pounds per square inch. Rho for the water is 62 pounds mass per cubic foot. We have the values of G over G sub C. The height of the water is 3 feet. And once again, I'm going to convert square feet to square inches because I want PSI. And so the pressure at level B, the gauge pressure at level B, is the gauge pressure at level A, 6.5 pounds force per square inch, plus an additional 1.29 pounds force per square inch, that pressure created by the column of water. And so we have the gauge pressure at point B is 7.79 pounds force per square inch. So that is PSI, that's gauge pressure, not absolute pressure. If I wanted the absolute pressure, I would have to add atmospheric pressure to the gauge pressure.